Oh, hi. I didn't see you come in. My name is Professor Professorson, and welcome to Science with the Professor. As you can tell, I'm a totally real professor because I have glasses. Now, we have two chemical reactions for today. Shall we get started? Our first reaction is a double displacement reaction between ammonium phosphate and aluminum chloride. To show you how the reaction works, I've color-coded each molecule, and I'll show you how it works. Ammonium atoms, which are green, our phosphate atoms, which are yellow, our aluminum atoms, which are blue, and our chlorine atoms, which are red. Here is our ammonium phosphate. Now that our ammonium phosphate is done, we need to make our aluminum chloride. Here is our completed ammonium chloride. Now we have our reactants. We have our ammonium phosphate plus our aluminum chloride. Now we need to find out what the products are. This is a double displacement reaction, which means parts of two different compounds switch places. Now, we all know that the non-metals in each compound have to be the ones to switch places. So, we know that the phosphate molecules and the chlorine molecules have to be the ones to switch places. So we can predict that our two products will be ammonium chloride and aluminum phosphate. Now, we know that our final two products are ammonium chloride and aluminum phosphate. Now we have our final equation. We have ammonium phosphate plus aluminum chloride become ammonium chloride and aluminum phosphate.
So next, we need to find the valences. So, we know that ammonium is NH4. We just make this 4 subscript. So, now we have our ammonium. So, next, we need to make our phosphate. So, and we know that phosphate is PO4. Make this 4 subscript. So, yep. Now we've got our phosphate. Sadly, this doesn't work because we know that phosphate has a charge of -3 and ammonium has a charge of +1. So we need to put this ammonium in brackets and make 3 of them. Now it does work because the NH4 has because there's 3 of them, has a charge of +3, and the PO4 has a charge of -3. So together they equal 0. Next, we need to do the aluminum chloride. So we know that aluminum is Al, and we know that chloride is Cl. This doesn't work either because we know that aluminum has a charge of +3 and chlorine has a charge of -1, which means that we need to make 3 of these chlorines. So 3. Now on this side we know that we have NH4, so ammonium. We also have Cl. Luckily, NH4 has a charge of +1, and Cl has a charge of -1, so they already balance each other out. So there doesn't need to be any more valences here. So next, we have our aluminum phosphate. So we have Al and PO4. These cancel each other out too because they both have a charge of negative and +3. So they cancel each other out too. Now we have our full skeletal equation.
We need to balance the equations because the way we have them now, atoms are created and destroyed, and the law of conservation of mass says that you can't do either of those things.
Now, using that skeletal equation, now we need to balance it. We know that we have 3 ammoniums here, but we only have 1 ammonium here. We also have 3 chlorines here, and we only have 1 chlorine here. So what does that mean? We need to put a 3 here. So now we have 3 ammoniums here and 3 ammoniums here. We also have 3 chlorines here and 3 chlorines here. We don't need to balance phosphate because we have 1 phosphate here and 1 phosphate here. And we also don't need to balance aluminum because we have 1 aluminum here and 1 aluminum here. So now that we've done this, the whole equation is completely balanced.
Wow, that reaction was thrilling. Now, our second reaction is a decomposition reaction where silver oxide breaks down to produce silver and oxygen gas. This reaction is a decomposition reaction, which means one compound breaks down into its separate elements.
For this reaction, we'll be using red to represent the silver and just white to represent the oxygen. So here is our silver oxide. Now, we know that it breaks down, so its products have to be silver
And, well, oxygen gas. Fun fact, silver oxide is used in batteries and has an oxidizing agent sometimes. A problem with silver oxide is that it may cause breathing problems, lung and throat irritation, and stomach pain if you are exposed to it.
So next, we need to figure out the skeletal equation. So, we know that silver is Ag, and we know that oxide is O. Sadly, this doesn't work, because silver has a charge of positive 1, and oxygen has a charge of negative 2. So, we need 2 of these silvers. Now that we have 2 of these silvers, this compound's charge is 0. So on this side, we know that we just have silver by itself. That already has a perfect charge. So now, we also have oxygen, which can't exist by itself, so it would be O2. Sadly, this equation also isn't balanced. We only have 1 oxygen on this side and 2 oxygens on this side. And we also have 2 silvers on this side and 1 silver on this side. What that means is, so that we have 2 oxygens on both sides, we have to have 2 of these, which also means that we have 4 silvers on this side, because 2 times 2 equals 4. Now we have a perfectly balanced equation. Yay!
Thanks for watching Science with the Professor. Turn in next time for absolutely nothing because we're probably never going to do another one. Take care. Professor out. Later, bruh. By the way, trust me, I'm wearing glasses. It's safe to eat chemicals